Hello friends, welcome to my channel. Let's have a look at today's daily challenge problem. Problem 219 contains duplicate 2. In this video, we're going to share a solution based on the routine dictionary and check idea. First, I'll read through the statement to digest the problem requirement, and then we do the analysis and share the shortcode. First, the statement. Given an integer array called nums and an integer key, return true if there are two distinct indices I and j in the array, such that nums I equals nums j, and the absolute difference of the two indices is bounded by key, right? In mathematical formula, that is, the absolute value of the difference between I and j is less than or equal to k. So here are several examples. So let's look at the first example. So here k equals 3. So if we look at index 0 and index 3, so they are the same. So we're going to return true in this example. So in example 2, so k equals 1. So the difference is 1. So actually we can look at the indices 2 and 3. So the return is true. In example 3, the return is false. Here index equals 2, right? So this one, so you can do over both check, so there's no such pair, so we return false. Before we look at the analysis, let's look at the constraints. First, this nums list is not empty, and its length is bounded above by 10 to the power 5. So 10 to the power 5 actually gives us the problem size upper bound. Secondly, it's about the range of elements in the list, so which can be negative. So this is the point we want to be noticed of. So thirdly, so k is greater than or equal to 0 and less than or equal to 10 to the power 5. So this one is roughly a consistency assumption because k is greater than or equal to its absolute value. So absolute value is non-negative. And also, if we take consideration of the first constraint, the length is bounded by 10 to the power 5. So k should be bounded by 10 to the power 5. So with that said, actually we are ready to do the analysis. So this problem actually is very straightforward, as it's marked as easy by Leetcode. So we can regard this as a routine practice. So this actually can be regarded as a variant of the classic two-sum problem. So here the method is again dictionary and check. So the procedure is as follows. So we're going to initialize a dictionary, and then we do a linear scan for the list. So what we do when we look at each of the indices and the corresponding numbers, so we do two things. So first, we're going to check if the current nums I, which is a number, right, if it's appeared in D. If so, we're going to check if the absolute value of the differences. So here I is the current difference, and d nums I will be the latest indices appeared. So actually here we can just use I minus d nums I without using absolute value because this I is larger one. So the reason we use the latest indices because we want the absolute value to be smaller so that it can less than or equal to k. So in this case, if this is the case, we're going to return true. So no matter what, we're going to update latest appearing index for the number nums I. So now we are going to update as d nums I equals I. After this loop, if there's nothing returned, so we're going to return false. So that's the idea. So the logic is very simple. So with that said, let's look at the code. So for this code, let's first initialize a dictionary, so which is routine. So now we do linear scan or linear traversal for this list. So for I, y in enumerate nums, so we're going to check if y in D. If so, we're going to check if the current index minus the latest appearing index, that is dy. If this is less than or equal to k, then we're going to return true. So no matter what, we're going to update this dy to be the latest appearing index. So with that said, so after the for loop, if nothing returned, so we're going to return false. So that's the logic for this problem. It's very short. So with that done, let's do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So with that said, I guess that's about it for this problem and for this video. Thank you.